Did y'all just hear that where it said this meeting is being recorded? You
I heard
did.
recording in progress.
That's new. That never happened the first, I don't know, whatever, 5-6 weeks we were doing
It's
this.
asking for consent.
It's asking for consent.
I had a window pop up that says this meeting is being recorded. By continuing to be in this meeting, you are consenting to be recorded.
Wow.
Continue or leave meeting.
So all of you see that. So it's telling me it's recording. That's very interesting. So everybody's seeing that same message?
Yes.
And
Yeah, I saw it.
Yeah.
And everybody clicked continue. Okay. Well, assume it's recording. Interesting. I didn't touch a thing. I didn't modify any. Anyway, for the recording, it is May 25th, and we're talking about visualization using the Python Seaborn library. Thank you very much, Lindsay. Okay. So yeah, back to what this thing is, this Anscombe object, this thing called Anscombe, is a pandas data frame. And I called it an object, and we haven't really talked about what objects are, or object-oriented programming, but that is a very specific term when it comes to Python and R and other programming languages. So we'll also go into that a little bit today. Okay, so yeah, this Anscombe data set, you've got a column that delimits which data set it's in. So this is obviously like pivot table type data, right? Where you would want to aggregate these things by data set. And then you've got an X and a Y, and it just looks like a bunch of numbers. Yeah, here's Micah. Just because we can create a plot doesn't mean we need to create a plot. So there you go. Matplotlib is another library that gets imported very often as PLT. It's just that's just the convention. So we can subset a data frame, and this is what the talk on Tuesday, June 8th is all about. It's all about this pandas library and how you can slice and dice rows and columns out of a data frame. So what this line of code here does is basically just grab everything out of Anscombe where the column data set equals Roman numeral I. So that's Pythonese for select star from Anscombe where data set equals I. I mean, so there's that's basically the gist of it. So now data set is a subset of Anscombe that is just data set one. And like we were saying, just because you can create a plot doesn't mean that that plot's going to do anything for you. And that's one of the reasons we went over the chart types. We've done that. But what chart types kind of match what kind of data? So if we do just a typical XY plot, especially connected with lines, we get gobbledygook. So that just shows you this matplotlib can create graphs using these functions, and you pass them parameters and it draws things for you. It makes a little more sense as a if you use a parameter to make a shape instead of this line, it starts to make a little bit more like a scatter plot. So that's just showing you that you can modify these plots, but everything is Python code. It's not like clicking in boxes like Excel and Power BI and whatnot. All of these graphs you control by sending parameters, either sending it the data to plot, or there are many ways to modify, and it's all in parameters that you send to one graphing command or the other. Okay, so yeah, like you can change the, we just use this 0 parameter to change it from like I'll rerun this. I think this will work. There's another parameter. If you can change it to plus signs. Let's run that and see if it. Yeah, I haven't. I got to run everything from the beginning. Hang on, just a sec. So let's run all and see what happens. Takes a little while. Got to import the libraries, and of course I've got errors. That's what happens when I go off script. And I probably blew all the stuff I wanted to show you. Hang on, see if it gets back to my what I want. Yeah, these are different plots you can draw. I wasn't going to go that far, but as I go back up, we got all kinds of cool stuff we can do. I wanted to show you the Anscombe data. Ah, there it is. Okay. So back where we were, up here, we went ahead and used that same command, and I changed the symbol to plus. So there's just, we'll get into it. There's just a ton of parameters for these different plotting functions in Python to change, like the scale, the colors. There's just but it's not as easy. Once you get it programmed, it'll do it perfectly every time, but it's nowhere near as easy to me as using a graphic interface. But some people love this stuff. Damon, you're an R programmer. You've drawn graphs using Matplotlib and other kind of stuff in R, right? Damon, you're out there, right? Yeah, Damon's there. Hey, Damon. Can you hear me now? Damon. He might have had to step away. Anyway, there you go. Plus signs for a scatter plot instead of circles, and there's many ways to change that. So this next block of code creates 3 more data frames based on that initial Anscombe data frame where the data set column equals 2, 3, and 4. So we can run a, it's called a method, which is, like I said, we'll get into that today because you need to know what a method is versus a function. It's a lot like a function. So there's this thing called describe that will do a pretty standard descriptive statistics set on a data frame. So here are the two. Here's the name of the data frame that we're printing here, and then these are the, all of them have 11 values. There's 11 values in each of the Anscombe data sets, of each of the 4 Anscombe data sets. So we see it's got a, data set 1 has a mean of 9, data set 2 has a mean of 9, data set 3 has a mean of 9, data set 4 has a mean of 9. So this has got to be the same data, right? And look at the, the X and the Y, same mean, same number of variables, same standard deviation, same min. Whoop, where'd it go? Where'd it go? There we go. Keep clicking on the border and it hides your output frame. So yeah, the data is identical, right? And then there's a print statement up here that that is the data type of one of these data sets, and that's where you see we've got a pandas.core.frame. Which is just a bunch of notation for things down inside of that library. But it's a data frame. So that's a data type, but really it's a kind of an object type. So anyway, we can plot them on their own, or we can plot them all together, and that's what this code does. I don't want to belabor the point. But again, we're using the 0 character. And this group of subplots inside of a figure object that we've created shows them side by side. So we see that data set 1 is shaped like that. Data set 2 would probably be some sort of, logarithmic line of fit. And then data set 3 likes to show how this one outlier, everything else is perfectly aligned in this perfect correlation, except this one outlier, but yet all the descriptive statistics are identical. And then, data set 4, that's the same X value. And except for this one giant outlier way out here. And again, that outlier is enough to skew the data back into being the exact same descriptive statistics as data set 1 and data set 2. So there you go. I kind of wanted to back up and give that Anscombe data set a little more treatment than Bill was able to give it in his lightning tour last week. And there, if you, like I said, it's spelled Anscombe. B-E, there it is. Anscombe, Anscombe. So if you Google Anscombe dataset, there's all kinds of examinations out there on it and how significant of an illustrator it was. Okay. Any questions on this stuff? We will go over Matplotlib and Seaborn and other libraries in a little more detail in future weeks. Any questions on any of that so far this morning? Questions or comments? I don't even get it. Wow, or a good job, or from anyone?
Good job, Dan.
Come on, Chaz, you're on the road. Are you still on the road with your husband?
Well, yeah, I'm on the road with a friend, headed back to
with a
her
friend.
house. But yeah, I'm on a little mini trip at the moment. But
are you on
working in between?
Are you on headphones, or can your friend hear me?
No, I'm on headphones.
You're on headphones. Too bad. I was wondering if your friend might be really impressed with the fantastic knowledge and data analysis that you're getting here.
Well, I am very impressed. I didn't realize with Python, I mean, I've not been, I've not used it this much, but the fact that you can plot out like that is really interesting to me, because I'm only used to visual type, like Excel, using that really to visualize the data. So this is really kind of interesting.
Yeah, I gotcha. I had no idea. I started learning Python a couple of years ago. And yeah, well, while I got the screen shared, there's
wow. Yeah, I see now why Jeremy is he's very Python pro. He likes Python a lot. So now I kind of get a glimpse of why.
There you go. So yeah, in Matplotlib, there's a pie method that creates a pie chart. There's different methods that draw different kinds of charts, and each of those methods have lots of parameters that you can feed into them. So that's one of the things I need to kind of back up today and cover a notebook. But first I wanted to real quick. So we got, plot.bar does a bar chart, plot.pie does a pie chart, histogram, plot.hist. And again, you can, using these parameters, you can jazz these up. You can, in the code, you can write them out as a JPEG or a PNG. so that they're then out on the hard drive and you can integrate them into some other display. So yeah, there's all kinds of good stuff before I start running into errors from, I play with these notebooks and I break things and I don't go back and fix it. And that's why when I run them, sometimes they don't work. So yeah, right there. Anyway, so that's plotting and libraries and why we visualize data and all that. And Anscombe, that was the main thing. Good grief, I took 32 minutes to go back and cover Anscombe. So let me file, close and halt that one. Now I got a presentation I'm going to go through. Stop share. But in the interim, if you would log into the classroom and down under Python, there are two new notebooks. One is, let me go, I think it's number 6, but let me go home. Down under programming in Python. There are 3 files I need you to download and put in your notebook directory. Let me share what I got here. So okay, I'm in the classroom and I'm down in the programming in Python module. So if you would, while I'm droning on about Gestalt principles, download Notebook 6 functions and modules, and this underlying business.py. It's just a text file, but .py is a Python file, not a Jupyter Notebook file, but just a raw Python script. And you can open it with Notepad. It's just got a few functions in it, but I'll use it in this this number 6 notebook to show you how you can write sub procedures, subroutines that do things, and you can put them out in a separate file. And we do an import statement that requires that business.py be in your notebooks directory. And like Chaz, you're on the road, you probably can't follow along, but holler if you can't get these to work when you get back home. And then download number 10, lists and tuples. We for certain we need to go through that prior to Dr. Ellis talking about pandas, because pandas relies heavily on these. Lists and tuples are a series data type where you can store more than one. I've kind of talked about them, but I haven't shown them to you yet. So download those 3 files, number 6, number 10, and this business.py. There's one more in between 6 and 10. You might have noticed a gap in our storyline. There's another one I'll come back to, working with files. But I wanted to cover these 3 for sure this week. So download those, and I am going to, one more. One more. In Foundations, towards the bottom, if you want to download my slides, they're nothing cosmic. Gestalt is covered like crazy all over the internet, but up in Foundations module, underneath the data visualization foundations, where I love that, how to spot a misleading graph, techniques for confusing the public. You'll see DAAT16Mar2021 Gestalt principles. That's the PowerPoint I'm about to bring up. If you want it, there's a link or 2 in there that you might find useful. So I'm gonna bring that up and yap about it for a minute. Yeah. if I'm still yapping at 9:15, holler. Let's see. Data analysis apprenticeship. Gestalt. I just like saying it, really. That's the only reason I'm doing this. New share. Okay. And this, these Gestalt principles, they kind of are the, well, no kidding. They're kind of the common sense between why we do certain things with line charts and bar charts and pie charts and Mersey-Dotes and Dozy-Dotes to highlight for people using that precognitive. It's human beings are wired to see things a certain way. So this just kind of good Gestalt practice sort of takes advantage of that so that it's a smooth communication between you, the presenter, and your audience. So yeah, these things are, and this is straight out of Wikipedia. German psychology. A lot of it was back in the 20s. It means form, and there are principles where they just kind of looked at the way humans perceive the world visually, and kind of what made sense, and then it has been sliced and diced and revisited, and so there it's not like some well codified list of principles. There's areas of Gestaltism and then sub principles. So I grabbed the some information about those shouldn't be there. That's a cut and paste error. Never mind the man behind the curtain. That's on the next slide. So I grabbed some that that illustrate, but the kind of the underlying premise is that your eye, the way you look at something, things jump out at you in chunks. They're not little individual things. You're not reading bits like a computer would. Images transmit a bunch of information to you instantaneously, and then we talk about common fate, where when things move in the same direction, we assume they're related. We assume they belong to each other. So here are the principles I was reading up on and wanted to cover because they have something to do with data visualization, and they get mentioned a lot. And like I said, guys, this is all over the internet. If you want more on it, YouTube and an internet search will bring up all kinds of stuff on this. But for the sake of making sure we cover this, I wanted to talk about the principles of proximity, similarity, connectedness, common region, common fate, continuity, closure, and figure ground. And again, if you download the slides and Google these terms, there are examples in everything from like traffic signals, the user manuals, even the way text works, even the difference between sans serif like fonts like Arial and serif fonts like Times New Roman. There's Gestalt principles, Gestalt psychology behind the way human beings perceive all these things. It's fascinating. So on to our first principle, proximity. Things that are closer together are just assumed to be related. Things that are proximate to each other. So we assume See how there's kind of a big northern chunk up here, and there's kind of in the upper right, and then the data kind of chunks together in the lower left, and there's almost a definable region between the two. That is the principle of proximity. Your mind is drawn to two groupings, whether or not they really are different. Really are. Your mind is drawn to them, and they may be, and there may be a reason for that. So that's why we. But there are a couple of other Gestalt principles that explain or that enhance, I guess, this perception issue. So um, so that's proximity. They're close together. Things that are close together belong together. The mind assumes that because they're close together, they belong together for some reason. Okay. And then similarity. We can use different colors um, or objects or shapes in a plot to enhance similarity. And we'll see this when we do a plot like in Excel. It automatically for two different series, it automatically picks a color, which may or may not be meaningful. So you can change that color, and you can change the shape of the object that's being displayed. So that, yeah, if things are similar, we assume we group them together in our mind based on color, shape, direction, because they are alike. The previous plot redrawn, this is actually each dot is a county, and the color encodes the state that it comes from, without looking at what we're talking about. So now you can kind of assume, oh, well, yeah, these are two different states. The population, whatever metric you're using might be different. So it starts to make sense that they belong together. But each of those two states has a different. They would show up differently in cluster analysis or some other analysis. So that's similarity. Things that are shaped together, using the same shape, using the same color, and that's why we, like when you have, a bar chart with, 4 quarters of sales data for 3 different products, you make product A the same color in each of those 4 bar charts, because that way, product A is the red product, and your mind instantly groups them together, and magic. 914. Okay, here's another principle of similarity. The pie chart on the left, green, pink, yellow, and orange. Your brain assumes they are absolutely distinct from each other, and none of the slices are related. But using shades of the same color in different graphs, and it can be pie, it can be other graphs. Shades of the same color make the mind think, oh, this what would that be? 100 and 200 degrees of this pie chart here are similar because they're different shades of orange. Is somebody trying to stop me because it's 9:15? I don't blame you. It's 9:15. So anyway, yeah, these blue wedges, your mind thinks they belong to each other. So if you didn't intend for that to be, choose your colors carefully, because the person looking at this pie chart on the right is going to assume that the light blue and the dark blue wedges have something in common because they are similar. Okay, so buyer beware, analyst beware. Okay, when we come back, we'll move to at 9:30. We'll talk about connectedness for just a bit. Okay, cell phone time, 9:30. See you back here. It would help if I unmuted my microphone. Okay. We are back with connectedness. And this example, things that are physically connected, literally, with a line, will seem more perceived as being similar, more so than if they're not connected with a line. And that's why the orange series on this scatter plot looks a lot more similar than the green lines, where they jump around. You're not really sure if it's sequential. Like the orange line kind of makes it, obvious, the flow of the data and that it's connected. So there are chart types in all of your major graphing programs where you can either just show the data points, or you can connect them with a line. And then you can even smooth the line and get rid of the data points. So there's lots of different options there. And I've got a small Excel spreadsheet I drew up last night that kind of shows those sorts of things. The next one, common region, is really frequent. Common region overrides other other perceptions very often. If you draw a circle around something, bang, the eye immediately goes to what you're trying to say. So, like for example, in this chart, which is the exact same plot as when we talked about similarity in chart number 5, the analyst is drawing a circle around these middle things. Well, it may be something similar. Those may be, remember, these are counties in 2 different states, the orange state and the green state. There may be something according to a model that makes that region something that you want to highlight, something that you want to stand out. But just realize this common region is a very powerful tool for making sure that your audience is drawn to something. And a lot of times in a charting program, you've got to insert a static circle or hand-drawn line. I haven't seen a whole lot of circumstances where they do this automatically. I think there are some cluster analysis tools, which is kind of advanced machine learning, or at least machine learning, that will draw circles around clusters of data that are similar based on characteristics and whatnot. So that's common region. If you want to draw attention, here's another example. If the colors weren't obvious enough for you, draw a line around the pie chart and label it, using drawing tools in a common region. Common fate is harder. That's the next one. Bill Shander talked about this one very briefly in Dr. Rosling's, that's the Swedish gentleman that was so effective at showing the movement, not physical movement of countries, but the movement of the data. Remember, in infant mortality, where the upper right corner in our view was bad, undeveloped, high birth rate, high infant mortality. You don't want to be in the upper right corner. You want to be down in the lower left corner. And he showed over time how some countries moved significantly from one quadrant to the next. And those countries that moved together shared a common fate, is the overall Gestalt principle. Objects that move together in an animation. And if you've ever been a PowerPoint wizard or worked with one, you can do animations. So that every time you hit the right arrow, stuff on the slide moves together. So you can do common fate in PowerPoint. I don't know. I have done them. They're a lot of work to get everything synced and grouped together, because you got to make sure all those objects are in the same group in PowerPoint, which is harder to do than it is in Excel, because you're in a data series. But anyway, yeah, you can do this common fate thing. You can show objects moving in a direction, and the human mind assumes it's for a given reason. They're similar for some reason. And I put a link in the slides here to Dr. Rosling's TED Talk, which is not the exact same video as we saw him kind of like behind the plate glass, smart window. So I thought it was a really good presentation. So there's two examples there of common fate. The one from our lecture that I recorded last week, and there's a TED Talk, and you'll see lots of examples out there, but it's in motion, so it has to be some sort of animated presentation, basically, or at least showing some sort of movement. Okay, common fate. Any questions so far? Everybody doing okay? All right. Okay, so continuity. We look at objects that are along a line or along a shape as being there's related, or it's for a given purpose. So like on the bar chart on the left, we have I would assume randomly aligned the product by product name alphabetically from left to right. And then we're looking at the sum of the sales by product. Well, if all you want to do is show that, and and have your audience kind of hunting and pecking and looking around, trying to figure out the rhyme or reason of the chart, okay, but continuity means the brain sort of makes more reason if you sort them from low to high or high to low. If there's some sort of a smoother shape to them, like in the left-hand bar chart, I almost wonder if there's a rhyme or reason between this almost perfect stair step between product E, F, G, and H, and that might be just a distraction. There, if you look at them, it's not as glaring necessarily in the other chart. The stair step is obviously still there, but they don't stand apart. It's just a logical sequence from D, B, H, C, G, A, F, E down to sorted by gross product sales. So that's continuity. If it's a jumbled mess, your audience will be looking around trying to make sense of it. But if there is a way to embrace continuity, they'll make meaning out of it much more quickly. Okay, and closure is the whole idea of completing something that's not there. Your brain fills in the gaps. So it gets used more in graphic design. I couldn't really find too many examples, although sometimes in a graph, if there's a gap in your data, the human brain will kind of assume things and sort of fill in the gap between information. But these are logos where the brain is making something out of nothing. You got the NBC Peacock logo. There's no peacock there, but these the different colors kind of are reminiscent of the tail feathers, and then just the addition of that little beak in the purple wedge, just that little thing is enough to make you go, oh, it's a peacock. There's its beak. It's looking to my right, to its left, and you sort of create something in your brain out of nothing because of this technique that your brain has for closure. And this one fund, I thought that was for graphic arts. I thought that was really interesting because if you look at what is above the word one fund here, it's three objects. It's three kind of not really particularly meaningful shapes, right? But then when the way they're lined up and the way the angles work, it's absolutely easy to see that it's an F, a one F, one fund, and they even used the angles correctly between the one, so that it's like at the corner. You're like looking at the corner of the one, and the one is going away from you on the left, and the F is going away from you somewhat on the right. Just, I don't know. I thought it was pretty interesting graphic design. And then the IBM logo is really classic for it because those are just a series of dashes, but because of the way the borders in those dashes align, you assume it's the letters IBM, and it makes the letters IBM. Pixels are like that. A pixelated image is really not what you see it, but you start to use closure. And have you ever seen one of those? It's a picture mosaic that makes a picture using a bunch of other pictures, and it uses each of those pictures as a pixel. And if you get right in close, it looks you can see the individual pictures, but as you back away, the software uses the overall color and warmth of each individual picture to be a pixel, and then you back away and wow, that's a whole nother picture. Fantastic. I'll bet you guys are thinking I'm a real hoot at parties, aren't you? When I start talking to people at a party. Yeah, well, it's a well-known fact, the Gestalt principle of closure. It's where the human mind completes an image that's not really there.
That's stick to the hat story.
Thank you, Thomas.
Or guitars, yeah.
All right, and the last one I chose is just really cool. You've seen these, figure and ground. The brain, tries to find the lion moving across the background, and staying out of trouble, from our survival instinct. So there's the brain tries to arrange things so that the figure is what is your focus, and the ground is the background. So like the generally speaking, like a small object on a colored background, where the background is larger, the brain sees the small figure, even though it's smaller, it's in the foreground according to your brain. So things to keep in mind. So has anybody not seen these? Anybody want to come online and admit to have not seen like this one on the right, especially the one on the right? Everybody.
Yeah, I haven't seen the one on the right before. I've not seen that one.
Do you see two distinct different images, Chaz?
No, I can just see the old
what do you
lady.
See? You see an old lady.
Yeah.
With with like her nose.
With the nose.
Yeah, and her lips.
Mm-hmm.
And the chin down there. Yeah. Well,
yeah.
Look at it again. But look at it such that the old woman's, her left eye is actually a young woman's left ear. And that young woman you're looking at kind of like the back of her head. She's looking to our left. The old woman's nose is actually her jawbone, the jaw.
Oh, I can see that.
Yeah, yeah.
Now that you say it, I can see it, but
yeah.
I didn't.
And
I couldn't see it before.
That's Gestalt. The other one on the left there is the famous, do you see the vase or do you see the faces? Generally speaking, the more detail you give to the foreground object, the more you'll see the vase. And all things equal, most folks in that black and white image, most folks see the two faces facing each other, even though they're both, it's identical. See, even the yellow vase, the faces are still there. So yeah, that's your brain. Your brain tries to make sense and rhyme and reason out of everything. Going back to, the constellations, Orion the Hunter. Don't you see the belt in the air? No, I don't. The Big Dipper I see. I don't get any of the other constellations. So there, that is a presentation on Gestalt principles. So use them as you will. A lot of folks, a lot of companies try and standardize the way they present information. Generally speaking, it's from the leadership tier down, you know what I mean? And they will tell you, if you're going to use this kind of chart, use these colors. If you're going to use, if you're going to use a line chart, don't show the data points, and do smoothing. You got to do, there's several ways to smooth data. So it all kind of depends on, and if no one is inflicting standards on you, it's up to you as an analyst, using all this kind of these sort of techniques and psychology to decide how you want to present your message, so that it's clear and accurate and concise and contains not too much information, not too little, and isn't misleading, and all of those sorts of things. So that file is on your, it's a good TED Talk. If nothing else, download that and get the link for Dr. Rosling's TED Talk. Okay. So let's, 9:49, let's move on. There was something in between. I got an Excel spreadsheet. I wanted to show a couple things related to our discussion we just had. Okay, let me share that. Stick to the hat stories, Don. Okay, so holler when you see a very boring spreadsheet.
I see it.
Yeah.
Okay, I typed this up last night. This is a series, two variables that have nothing necessarily to do with each other. Factor 1 and factor 2, and then a month, at like a month 1, month 2, not February, January, February. So we're doing some observations, and we did 20 months of observations. So we got data down to row 20. So if I click in that data field and I go insert, and I'm looking to insert a chart. Say I wanted to insert a scatter chart. The first one I'll pick is just a typical scatter, and it automatically charts out my my two factors, right? So we automatically get similarity. We get the Gestalt principle of similarity, because the blue dots belong with the blue dots. That's measurement one. It's just dummy data. So whatever factor one means. And we know the orange dots go together. And those are factor two. But we don't have, I mean, they kind of meld together, don't they? I mean, because you've got similarity problems. You've got, and I did this on purpose. You've got the data zigging and zagging back and forth, intermingled. So your Gestalt principle of similarity is proximity. I beg your pardon. You've got similarity between the orange and the blue, but proximity is making me think that, you know, maybe these dots are related, so I got to think. You know what I mean? So one of the things you can do is if you right click on a chart in the right way, big menu comes up. Yeah, change chart type. So you can change it so that it has either, you know, sharp lines, straight lines, and markers, and that brings in your connectivity to override the proximity confusion. So now these lines going together, we kind of, I'm starting to see they're, you know, zigging and zagging. Yeah, they one time, you know, during 1 month, one might be bigger than the other, but it starts to understand that. It starts to, you know, to highlight that fact. And then there was something we were doing. I don't remember if it was Bill Shander or something I was reading or what, but folks tend to hate those data marks unless there's, I think Bill mentioned it, unless there is a particular reason to show these, the marks on the chart. Generally, folks take those off. And unless there is a reason to show the jagged between data points, what can be more, a little more visually soothing and maybe even more meaningful is to use a smoother change chart type. There it is. To use smooth lines, and that's an option you can choose, scatter with smooth lines. And it starts to use math to smooth the transition between data points by like averaging the previous data point with the next one, and that's how it draws that smooth line. And there's a whole discipline, different ways to smooth data that have different effects on the data. So anyway, that's that. And all right, this is 5 minutes of ridiculous fun. But I wanted to show you something that I'd figured out. You guys may be all over this, but let's go back and change our chart type to our original. And I wanted to see how easy or hard it would be, because remember we got proximity kind of confusing our similarity rule here. So I went down here and I wanted to insert a little icon, and I will insert, let's say okay, these are modes of transportation, factor one and factor two. So we'll insert that one. I gotta get my stuff down. Insert that one. Okay, so we got a little airplane icon down there now. All right, so click somewhere else and insert an icon. So I wanted, say, factor one and factor two maybe are boats versus planes. I don't know. Anyway, like I said, this is just numbskull fun. Okay, so if you can, each of these objects, you can resize to be something a little more chart friendly. Shrink those down a lot, and since they're both black, that blows our similarity problem, right? We don't want them to be seen as similar. So let's click on the anchor and we'll make it, where's the style? There we go. We'll make it orange instead of black, say. So we got a black jet and an orange anchor. So let's say factor 2. So we got that highlighted. So we copy that. And if I double click on a factor 2 data point and hit Control V, it pastes an anchor in the place of that little default little orange dot. And you can do that with anything, any image, anything that adds meaning to your chart. And similarly, if I copy that little airplane icon and I double click on a factor 1 and hit Control V for paste, so now we've got color and shape and kind of and different symbology on a chart. So I thought, oh, hey, that's way better than if the icons themselves were different shapes. And there's other ways to go about this, using little squares versus the circles and stuff on graphs. But it's just something to keep in mind when you're drawing a graph. The more clear the differences are for your audience, the better they'll be, or the more easy to consume your visualization will be. Any questions on that? Isn't that cute? Come on, I get a golf clap? Wasn't that cute? Now, Laura, have you ever done that before? Have you ever cut and paste a little airplane or an anchor onto a PowerPoint chart like that?
We've done it for like dollar signs to show like when something's sponsored, like a paid promotion or something. Yeah.
There you go. So yeah, so everybody looks at it and instantly knows we're talking about money. Yeah. As opposed to, on this one, we're talking about ships versus planes. But yeah, that's another of Gestalt principle that's out there. It's called past experience. You see something what it was before, or you think it's that again, even though just because of visual cues. So yeah, you associate the dollar sign with currency. All right, let me get rid of that. What do we got? 959. Okay, let's bring up that notebook 6, and we'll talk about an important concept in computer science and Python programming. That is subroutines. Get out of the grading, submit. Okay, number 6. Pretty sure I cleaned that up. When you brought it up, none of the cells were run, right? It was a notebook with code, but there was no output, right? I cleaned it all up.
Looks like they're all markdowns.
Yeah. Well, there's code cells. Yeah. And if you scroll down, you'll start seeing the code cells. But okay. For this segment of Python programming, we need to talk about the concept of a function, which we have seen. These are just like those SQL functions, where you're selecting the substring of something, or you're selecting the right 3 characters of something. Same concept in Python, so it shouldn't seem unfamiliar. But we'll go through the syntax here, because you may have something in your Python programming that you do frequently, And if you are repeating the same code, even just a few times, it's probably best to put that code in what you would generically refer to as a subroutine, but in Python, they're called functions. So groups of functions that perform maybe some similar task, or you want to keep them together for some reason, can be put in their own module, and that's what that file you downloaded, business.py, is what you would consider a module. And for really popular modules that are more or less built into the Python language, you've got what's called, or they call them library. So a library and a module of functions, it's kind of used interchangeably. So, but you pretty much get used to it. So yeah, modularity, if you're writing a long Python program, and again, like you say, if you're constantly computing the tax or whatever, and using the same, 2, 3, 4 lines of code, or the same for loop to do things over and over again, you probably want to put that in its own function. And then instead of repeating those lines over and over again, you would call them like you do a built-in function one time. And that's the concept of modularity in computer programming and in computer science. So that if something changed in the way you do that little function, you change it one time and it's correct for everywhere that function is being used. So that's the motivation behind. And you can read those 4 bullets under why do we want to create modular programs. And almost entirely this split up between team members. You as a software developer, you would get a specification for a function or an object or whatever, and it would have certain inputs and certain outputs, and you write to that specification. Then everybody else can use it, but they don't really care how you programmed it. Kind of like in that first Python homework, some of you used a while loop to do 5 times instead of a for loop. As long as it works, nobody using your module really cares. But if you find a better way to do it, maybe something that operates faster, like a sort routine or a search routine, there's ways to make those execute faster. Then you can change the module, and the people using the module don't care. They don't, nothing changed. They don't call it any differently. They don't send parameters any differently. It just works better. So that's a great reason to do that. Yeah, top-down design. Again, this is kind of basic computer science. You can decompose what you're doing. You may know that you need to calculate tax rate, and you can, when you're kind of designing your program, sort of writing it out in PDL, thinking it over, you can just delay what that means and just kind of move on with the design of your program. There you go. Now, and again, that's top-down. That's something you teach a computer scientist really more than an analyst, but it's why you see sometimes some pretty cranky code being written by analysts, because they think more like analysts, which is getting the answer, versus computer scientists, which think a little bit more about reusability and understandability and maintainability of the code. So end of the sermon. Variable scope. Okay, so we have seen this and talked about it before between notebooks. When you open a Jupyter notebook, you get a fresh copy of Python associated with each tab in Chrome with each one that is each individual notebook. So if you have, you know, my variable in one notebook, and you assign the variable, the number 5 to it, you can use my variable in another notebook and it has no idea. They're two completely separate memory spaces. That's why when if you have 40 Jupyter notebooks open, it might start to hit your memory because they all have an instance of Python running independently. So that's an idea. That's an example of scope, which is, where inside of Python can a variable be seen and used, and can you get errors for overlapping them or using them wrong or whatever. So we'll get into that a little bit. A local variable, and again, local and global, these are generic computer science terms. A local variable is local to the subroutine that you're using it in. A global variable is valid anywhere in the entire program. So you could write a little module that calculates the tax rate. I've been using and you can use the word tax rate, tax underscore rate. And that tax underscore rate will only be visible inside of that chunk of code that you wrote to compute the tax rate. You can use tax underscore rate out in your other Python program, in the main program, and they are two different variables. It's only inside of the function. So variables are local to the function that they're declared in or used in. Okay, so just for readability's sake, I try and make things a little more meaningful, but we need to show you the idea of variable scope in here. Okay, so you can have two variables called name, and we'll show you here this in a minute, and they can both be called name, and as long as one's inside of a function, the other is not, they won't. They are different. All right. And two kinds of functions. If you've programmed in other languages going back, some languages will call a function that doesn't return a value. It just does something, and execution comes back to the next line after that function call, is called a void function. It's not a function like substring or that returns a certain part of a string, or like int. The int function returns the integer data type of whatever you sent it. Those are value returning functions. A void function just does something. So you can pass it parameters, but you're not going to get like an answer back that you can assign to something else. We got examples of all that here. Okay. Okay. So first one here, defining a void function is right here in the highlighted area. You use the def keyword, you name your function, and then you have an empty open paren, close paren. Now that's a void function that doesn't get past any parameters. It's not, ma'am.
Are you meaning to share screen?
Yes, am I not?
No. I was lost.
No kidding. Good grief. When you've got an idiot on the other end of the microphone, you got to be on top of me more, man. Well, yeah, I should have been sharing my screen, but are you guys in the 06 functions and modules notebook? So you kind of been reading along. Yeah. Okay.
Yeah.
But I will still share my screen. Okay. So yes, inside of that, this is where I'm at. I'm at the very first code cell. inside of that function. So this is a void function, show me, doesn't return anything. It just does some stuff. And we didn't pass it any parameters. You still got to have the open paren, close paren for the syntax. But we didn't pass show me anything. Okay, so if we run that, we're gonna, it won't matter what we type. When we press enter, it's gonna call show me. Show me down here in the code is where it executes. This def statement, this whole block of code, just sets up the show me function as something that can be used. It doesn't actually do anything until you call it by invoking its name. Show me. Is that making sense? Display
so,
line of
is it just the order of operations there? Like if you put show me, it's after input. So the user has to input first before show me will run.
Yes, in this code block, it executes from top to bottom. So the define statement executes, but nothing happens because you're just defining it. You're just setting up this thing called show me in memory, giving it a name, and giving it some code to execute, but you don't actually do anything with it. And then the next line to execute is the input statement. And then the next line to operate or to execute is show me with no parameters, and that invokes the function. So that's where it actually happens. And then we got the print. The next thing to execute is the print statement with back to the main code, and then we do a calculation. So those are just to show you that show me gets defined first, and then it gets used down subsequently. You know what I mean? The definition comes first in the code. Did that answer your question, Laura, or did I read too much into it? Okay. So yeah, it executes, but it doesn't do anything because it's a definition. It's not using it. That probably makes more. I mean, I'm sure. Holler if that doesn't make sense. Okay, yeah. Here's a good example. In this next code block, all we're doing is defining a void function called input function, and if you run that, it's not going to do anything. But since we're in Jupyter Notebook, any cell that you run sets it up in memory. So now we have a function called input function that we can use. And then here's another define, output. Nothing happens because you're just defining it. Now this next block shows the issue of variable scope. Well, before I move on to the next block, because we're gonna redefine input function and output function. So let me go up here to this. Let's insert another code block. It's 10:15. Okay. I am going to be able to get through all of this today. I am. But we should go on break. Stretch your legs, check your email. Mostly stretch your legs. Hopefully you guys aren't sitting down all day. You're too young to be broken crotchety like me. Get some exercise. If I knew I was going to live this long, I would have taken better care of myself. Okay. See everybody back here at 10:30 cell phone time. After the buffoonery, this meeting is now being recorded. All right, so let me go back to, I cleaned up my example a little bit. So hopefully this makes a little bit more sense. Okay, so unlike what you have, I combined the two cells, one that the one that declared the or that defined the input function, and the one that defined the output function. And then I called each of those. So notice that inside this code cell, we have a function that uses the word name and gets that from the screen. And then we have defined a function that prints a line and then prints the same variable or a different one. And then down here, so those are just definitions. And then down here, we call each of those in order so that they will execute. I am sharing my screen, right?
Yes.
Yes. All right. Okay. So what's going to happen here in this cell that I'm highlighting? What's going to happen? What's my output going to look like? What's the future?
Is it going to display text that just says this line is found in the input function, and then beneath that, will it print your name? What is your name ? That, it'll print that line, or will it be on the same line?
Great question. So the order of execution here is top down. So these define statements don't do anything. They don't print, they don't ask for input, they don't do anything. They just declare those functions so that they will be acceptable syntax somewhere else in your program. It just sets them up in memory so that they can be used. So the order of operation or the order of execution is top down, but the first time input function or output, the function I have called output, execute are these two lines. So the first thing that will happen is input function will execute. So the first thing you'll see on the screen is this input statement, and we should see a prompt. It's what is your name, where I can enter my name, right? So we all agree that. So it'll get my name from the screen. And then down here, we execute output. So, and then when we go look at what output does, it's going to print this line is found in the output function. And then we assume it's going to print name that we gathered in the input function, right? So this is just to show you variable scope and an example that this name is not this name. In fact, this name, if you print something before the computer knows what it is, it'll error. So that's what we're going to get here is an error message. What is your name? Don. This line is found in the output function. Name is not defined. And you would be justified in saying, yes, it is. Name is defined right up here in input function. But they're not the same variable. They're not the same name variable. Name in output is only visible in output. And since inside of the function, I haven't defined it, when I go to use it, I get the not defined. I don't know what you're talking about, error message. So that's just an example of this whole idea of variable scope. And if we had a name down here, I'm going off script here. this name Bill is different than the name that we defined up here in the input function. I'm trying to think of a way for me to prove that to you, and I'm falling short, but it is. So if I run that, what is your name? Don. Oh yeah, because we called output. So let me comment that out. Because I even though I define name in the main program, yeah, pound sign, run it again. What's your name? Why do you keep asking me what's my name? What's my name? Bill. What's your name, Don? Bill. No. So there are two different names. Variable scope. Global variables. Let me see if I can do an example of a. I got an idea. Okay, let's create a variable called global name, and it's Bill. So I think we've proven that out here in the main program, we don't anything declared in a function is local only to the function. So if we use name out there, it's not the same name as inside one of our functions. So let's create something called global name and put it up here. Okay. So we have created in the main program, outside of the functions, here inside of this, we will print I think I might be getting ahead of myself. I think I do this kind of in the next block, but well, this is the way my mind works. Local input function name is, and then we will print name. And then inside of here, we will print, and again, I'm going so far off script. And then we'll print global name. So, and this may blow up. I'm thinking that in the main program, global variables are visible inside of functions, but not the other way around. It's like it's encapsulated inside of a function. So if this blows up, never mind the last 3 minutes of your life. Let's run this now. And we are going to run. So we're not even running output. Output's defined, but we don't even use it. Okay. What is my name? Don. Local variable input name is Don. Global variable is Bill. So you can use a global variable that is out in your main program inside of a function, but any variable that you declare only in the function is local to that function. And that's just something you'll have to play with to get locked in. But I think I proved that. Did I prove that to you, Andra?
Yes.
You're satisfied. Okay. I think, and the next block, I renamed the functions. I put a little 2 next to them because you can redefine functions, but when you're using Jupyter Notebook, it just kind of bothers me. So I went ahead and changed the name to input function 2 and output 2, and I called input function 2 and I called output 2 down here. So I think I got completely separate functions now in this next block of code. So let's see if I didn't blow that up. Okay, so this block of code sets a global variable, Silvio, and then inside of, and then after that, so you, a function declaration doesn't have to be at the top of your code or whatever. It doesn't really matter. But it is just a declaration, and everything inside of that define statement, that def statement, just sets it up for use. It doesn't actually execute. So here we are. This is the main body of the code, and we have defined name to be Silvio. So now we've, inside of these functions, output 2 should blow up. We're not using name. Sorry, talking to myself. Okay, what's my name? Gone. Ah, there you go. Now I remember what the point was. Because we used name out here in the main program, it's now defined. It doesn't blow up anymore like it did in output when it wasn't defined. This name is the global name Silvio. So when we run input section or input function 2, we get a local name and we print out the local name, which was Don. And then we prove that our global name remains Silvio, and I didn't overwrite name when I typed in Don. So all of this is really bad practice. I try not to reuse names like this. It's just shows you how Python works. All right, let's move on. So you can use, if you're a C programmer or a Java programmer, you're going to want to use, your main program will be a function. And Python allows that sort of syntax. I mean, you can do it, but it doesn't really change anything. You define a main void function, and then you call it in your code. You don't have to do it, but if you start downloading Python code from the internet, a lot of people use this convention. So I guess that would be my main reason for covering it, is that so you're not totally thrown when you do see it. But it doesn't really change anything, guys. It's the main program, yeah, but it's just a void function, just like input function and output there. But it makes it makes C programmers happy. So again, down here we define the main program, but we don't call it until the very end of this code block. But the concepts are all the same, so don't let that throw you too much. And I don't know that I don't know that we'll cover this again in all of the analytical libraries and programming exercises. I'm not really worried about defining a main program. It hasn't been anything that's really needed to come up that I remember. But here is this code cell that does that. So we define a main, but what I wanted to show you is a void function that takes parameters now. So when you pass parameters to a function, you can use them inside the function as local variables. So I need to show you how that's done. So inside of main, we set up, all we're doing is getting 3 floating point variables from the user, and we're calling a function called break even. That's all our main program does. So 3 input statements, and we call this function break even. using the same three variables that we gathered input using, right? We gathered fixed cost, variable cost, and selling costs in a little break-even exercise. And we passed them in this order: fixed cost, variable cost, selling price. Now, inside of break-even, notice that we didn't call it fixed underscore cost, we called it fixed. This is in the declaration section, the definition of the break-even function. So you don't have to use the same names at all, but the values will be passed in that order. You see how fixed cost goes to fixed, variable cost goes to variable, selling price goes to sell. Now, inside of this function break even, we are printing break even units that we calculated. We calculate break even units based on these local variable names that are the receiving parameters. So you get that they can be two different names on either side. In fact, when you're using a module, you don't even know what the variables are called inside that other module. If you're calling something from a library, you don't know or care what that programmer named these variables. All you care is the variables that you are setting a value and passing to that function. Okay, so that's all break even does, is does our little break even calculation and print the break even point. So when we run main, it's going to do our three input statements. It's going to run that break even that break even function, which just prints it out, and then it's going to end. All right, so everybody tracking on that?
Yes.
Okay, so we'll run that. Fixed cost, $1,000, say. Variable cost, we'll say 30. Selling price for 50. So we break even at 50 units, and then it ends, and that's that. So yeah, that's just to show you the scope and passing parameters to a function that you create as a programmer. Okay. So now look at this one. Take two, same stuff, different parameter order. So we've got the same thing. We're defining a main function, and that main program, all it does is gather three values, and then it calls a function called break even, and it calls it in order of sending it fixed cost, variable cost, and selling price. But now notice the break even function. It's calling its variables sell, variable, and fixed, not fixed, variable, and sell. So hint, notice the order. So what are we thinking is going to happen?
Is it going to error?
It's going to screw up. But watch. When you run it, go ahead and run it, and I'll enter the same values as I did last time. 1,000. It uses the same math. The formula is the same in break even down here. And remember, when we rerun this, we're redefining the break even function. It's like adding a new value, or it's like assigning a new variable to a variable. What came before is erased, and now it's got this new value. Well, now break even is a new function because we're reusing that term. Again, bad practice, but that's what we're doing. Okay, so $1,000 fixed cost, $30 variable cost, and we're selling them for 50. So now we're passing those same variables, but we're doing it in the wrong order, and now we get break even as 0.05. So that just highlights when you're calling a function, you got to get the parameters in the right order. It doesn't. it doesn't associate them by name. It associates them by the order they're in the function call. And that's it. And then this next one is just, and I'm glad you guys are going to get to meet Mike on June 8th. He's got a great sense of humor, but it's dry. He's not a absolute buffoon like I am. But anyway, so we got our main define here. We're defining our function main, and we're gathering fixed variable and selling price again, and we're sending break even, fixed variable and selling price. But inside of break even, this is just showing you that you don't care, and it doesn't matter what the variables are called inside of a function. Here he's calling them bread, apples, very small rocks. And instead of break even point, it's toad suck days is equal to bread divided by very small rocks minus apples. That is the formula. So when you run that, and you type in the same data I did before, $1,000, $30 variable cost, $50 sales cost, you get break even at 50 units. It doesn't matter. It's just really, it's just bad practice. And again, within a program, just for readability's sake, if it's in the same file, especially, the same visual space, try not to overuse values like that. Okay, so those are void functions, right? So they did something. They were a subroutine, a sub procedure that did something, but it didn't do any calculations and then give you something back in the form of a return value like we're used to with other functions in other languages. But we can do that in I almost said Pascal, in Python. And all you got to do is put a return statement at the end of your function, normally at the end. Cool Python trick. Let me see what Mike's got here. So sometimes we want to perform a calculation and return a value, correct? Creating returning value function allows us to create one time and use it repeatedly. Yeah, like if you had some cool matrix of stuff and you wanted to look up based on X and Y and find a value, like maybe in a pandas data frame, you would pass X and Y and it would return the lookup. And the logic to do like maybe error handling and type conversion and any weird stuff would go in that value returning function. And then you only got to change it there that one time. So it's very similar. We just put a return in the function, and we have to have a variable that we are returning. So whatever you're calculating in that function that you're going to pass back to where the function was called, or is got to be a variable name. The void function call stands on its own. Correct. You can just say, like we did, input function or main, just like that. You don't need to say my program equals main, like you would in a but in a value returning function, it's got to be assigned to something, right? You got to say A equals input function of something. And you got to watch out for the value can return can be any valid type. It can also be a string or a Boolean. So you can do, like, there are string functions that return, maybe the first 3 characters or the left hand 5 characters or the right hand 5 characters, or they return the string that you pass it changed all to uppercase or what may have you. But yeah, don't think just in terms of numbers when you're talking about a value returning function. And if you want to return more than one value, put them all in the return statement separated by commas. So you can, you can return variable 1 comma variable 2, and they go back in order. And we have an example coming up later. Okay, remind me, who's not a programmer, never is learning the bulk of what they know about programming from this course? Somebody fess up. Chase?
Yeah.
Thomas? Okay. Chase and Thomas, am I going too fast, too slow, or appropriately?
I think it's okay.
They're fairly appropriate, yeah.
Are you wishing that would speed up,
circle
Chase?
back around, and I'm usually keeping up. So,
okay.
Like I said, the explanation seems fine. It's just whenever it comes time to the practical application of it, it always takes me a couple of tries. But yeah, as far as what you're doing is fine.
Okay. It's very difficult for me to gauge whether I'm crawling or flying. So I appreciate the feedback. Okay. So in this next sample, we've got our main program, and we don't have to write it that way, but we've got a main function. And all it's doing is gathering our three break-even variables that we need. It's assigning to the variable result the results of a call to a break-even function passing the three variables, and then printing result inside of a string. So then we define our break-even function using those three variables that we passed in. Fixed cost becomes fixed inside of our function. Variable cost becomes variable, just like before. And then we do our break-even formula. But we've got the return statement now. Return break-even units. But break-even units is just this local variable. Break-even units doesn't exist for main because it's down here in our break-even function. So we're returning it because that's what we calculated. We calculated break-even underscore units. And now that what is in that value gets assigned to result. Almost like saying result equals 1. The value 1 gets assigned to result. This is the exact same thing, but we've written it ourselves instead of it being an internal built-in function in the language. And that's it. It operates the same. When we run this, it's going to be imperceptible, imperceivable, undistinguishable, indistinguishable from previous iterations. It's just written differently, and that's modular. That's the beauty of writing functions. Okay, so now we're getting to the end of this one. Yay, getting to the end of this notebook. So we've got remember our good old cloud cover function with our if, elif, else. So here we've got we've covered it as a function instead of last time. I believe we asked the user to enter something and we calculated the cloud cover in that code block. But now because calculating the cloud cover based on a parameter is so complex, we've moved that code into its own value returning function. So we get hang on just a sec here. That's going to error. Has anybody run this yet? Has anybody run this yet? Nobody?
Yeah, it's a long line.
Of error, right?
Yeah.
Yeah. Can you see why?
And invalid syntax is
Yeah.
but let's see, line 6.
I mean, there's something about the code in the cloud cover function that is jumping out at me as it's going to error before I even run it. What's jumping out at me is that we're passing the input parameter is cover percentage, right? CVR underscore PCT. But if you go down into the guts of the function here, at what it's processing on, it's called COVER underscore PCT, which doesn't exist. So I'm going to run this, and I thought I ran all of these, but that should blow up. The percentage of cloud cover is 40. It didn't blow up. It says partly cloudy. See, this is using the global variable cover percentage. That's why it didn't blow up, because we're using cover percentage here. COVER underscore PCT, which is the global variable, which kind of makes it a little pointless. I think in here it would be, and I'm just going in and deleting the vowels out of cover descriptor. This should be operating on its past parameter. You know what I mean? This function, you really should use your local variable that gets passed in, as opposed to the global variable, because it could get confused. So I'm thinking that's a problem. But let me run it again and make sure I didn't blow it up. What is the percentage of cloud cover? 40. Partly cloudy. Yeah, it still works. Does everybody see what I did there? We weren't using this local passed in parameter inside of the function. We were using the global variable, which can screw things up. That's the beauty of variable scope, is that if by chance there's an over, you're using the same name, you can count on your local variable being what it's going to be inside of the function. So anyway, there you go. That's our cloud cover calculator written as a function called cloud cover. Okay, now 10 more minutes and we will finish this notebook. This next one, I just really need to make sure you understand what math is part of the Python standard library. So there's no math file in your notebooks directory, but you do have a business.py. It will look, the import statement will look for one or the other. And you'll be able to use any of the functions that are declared inside of those modules. So let me real quick show you what's inside of business.py. Might be easier for me to do it. Business.py. New share. Business. I've equated it as a text file. So so this is all business.py is actually Mike Ellis has taken some functions and put them in a separate file, which if they're similar and especially if it starts to get large, you want to put them in a separate. So this is almost like a library of business functions, but the generic term is module. Okay, so that's what's in. It's just a text file with Python code in it, and you can see the functions. It has a function break even, a function called markdown, one called sales tax, and one called grade lookup. Okay, that's nothing cosmic about business.py. Math, on the other hand, is your part of your Python standard library. So so there's no math file to go find. It's out there, available, but it doesn't need to be in any given directory. Okay, so if we run that, we can see we're back in this code cell. We're not doing a main function. We're back to good old-fashioned straight line code, which makes it a little bit more fun. Or makes it a little more understandable. But you see, we're calling functions within the business module, and the way you do that is dot notation, very similar to table.column name in SQL. So whenever we want to call something, if math does some cool calculation of standard deviation, say it would be like math dot standard deviation. So all of the functions inside of business we call by calling them business dot sales tax, business dot markdown, those sorts of things. Okay, so if we run this, we get the result of all of those functions without ever really knowing how they work, right? Tax amount's $875. Original price is 100. Enter discount percentage. We'll call it 0.3%. New price is 97. Calculated discount is 3. Discount rounded up is 3. And you can see where these values are coming from in the different print statements. We're calling the ceiling function out of the math library. We're calling that markdown function out of the business library. So that just kind of shows you, modularity and external functions. Some of them are, well, they're not really built into Python if they're in the standard library, because they're in the standard library. And if you import, if you have to get to it, if you have to do an import to get to one of the standard library functions, you have to use that dot notation. It doesn't become part of the language. You always have to say module dot function name. Okay, and an ID number so that we do the Monty Python stuff. I don't know what the ID numbers were. Well, Lancelot is an ID number. There you go. Okay, and woohoo! Got to the end of this notebook. So here is a coding challenge for you. Yeah, excellent. It's 11:09, and we've got one more notebook I want to that describes a new data type, or a couple of different data types that act very similarly, and those are the arrays, basically, in Python. They're called lists and tuples, and lists and tuples are pretty critical to understand, because that's how pandas, and that's how you deal with a data set is in a group or a list of things. Okay, so it's 11:30. Take a break, get up, stand up, stretch your legs, but in the intervening 20 minutes, if you would please take a crack at this programming exercise below. The formula is there. You just got to write a function that does it for you. Write it in the form of a function. So, gather input from the user. You're going to want to pass parameters, right? Looks like you got to pass 2 parameters. A value for Celsius and a value for Fahrenheit, and then return that value, because it's a return function, right? It's not a null function, a void function, sorry. And returns it and writes it out to the screen. All right. See you back at 11:30. Take a shot at it. Questions on what went through? Anything really hang you up? Just like you said, though, Thomas, probably a little bit of hands-on.
Yeah, I think so.
All right. We'll see you back here in 19. It's really loud in my headset. Okay. Who is most proud of the fact that they wrote that and it works? I want the most proud person to jump up and down. Can everybody turn your camera on for me real quick? Can all y'all turn on your cameras? Nice to see you, Chase. Hi, Andra. Nice to see you. Hey, Chaz. Aaron. I haven't seen you. I mean, Aaron, I'd walk up to you on the street and I wouldn't recognize you. I don't know, guys. I'm a camera guy. Erica, Gabe, Lindsay, what's up? I mean, if y'all can look at my bald head and my gray eyebrows, you can let me know for just a moment that there's human beings on the other side of this camera. Have you stepped away from the... Hang on, Gabe, my iPad died. Hold on, I will open Zoom on my phone. Okay, that's a understandable get out of jail. Lindsay and Erica, what's going on with you guys?
Erica had to step away for a bit, and okay, every time I turn my camera on, this whole entire website crashes. So. Okay.
All right. Well, thanks to everyone else for letting me know that I'm I'm not all alone out here in Zoom land. I appreciate it. If you are more comfortable with your camera off, please feel free to turn your camera off. Okay, but first, before you do that, who's most proud that they got it to work, or who got it to work? I'm kind of expecting, Aaron, you turned in stuff kind of done.
I did get it, yeah.
Yeah, Laura, you tend to turn in stuff that execute. Did you get this one?
Yeah, it seems too simple based on what we were just covering, but it works.
but you got it, yeah. Chase, how about you? You're fairly new to coding. Did you get it to work? You're still on mute, bud.
Sorry, I did not get it to run, but I did get started. Just not quite right yet.
Okay. Well, rather than letting one of us that are coders, I mean, I got it to work during the break. Hi, Gabe. Thank you so much. Chase, why don't you be the victim? And if you think you're close enough that we could walk through it and get it to work on your screen?
Well,
let's give it a shot. And let me, I probably have to enable advanced sharing options. Let all participants share. You should be able to share your screen now.
Where do I go? Oh.
At the very bottom should be a green share screen.
Okay. Okay. Is it going?
Yep, see your screen. Looks like Newfoundland or something. So seeing your desktop.
Okay, how about now?
Yeah, there you go.
All right, that's where I'm at so far. I think I basically just kind of stuck on the result.
Okay. Well, first off, get yourself a blank line at the top, and remember we're defining a function. So you got to have that def statement, def space, and then I called mine what, Celsius to Fahrenheit or something like that. No, that's the parameter that goes in there. It's def and then space and then the name of your function. Yeah, before the parentheses. So you could call it temp convert or whatever you want to, you know. Okay, then you need your parentheses because you our instructions say write a function that accepts a float value for temperature in Celsius, in degrees Celsius. So you're expecting somebody to pass you degrees Celsius. So what's a meaningful input variable name to use inside of your conversion?
Well, is that not what I have there?
Yeah, but that's down in your main program.
Okay.
So what might help with readability is to put a few blank lines between your first and second line. Go to Celsius equals and smack return a few times and get you some blank lines in between your function and your main program. There you go. So inside of temp convert, we're passing it degrees Celsius. So you're gonna need degrees underscore C or C underscore degrees or something. You know what I mean? You want some variable that is you're passing it Celsius. So that needs to be a C, not an F.
Can I can I not share? I'm all kinds of turned around now. I'm sorry.
Okay, sure, man. But thanks. That was brave. I'll go ahead and I'll go ahead and stop share.
Let's see. See.
Somewhere, maybe down at the bottom, if you move your mouse down to the bottom, you can say stop share. There we go. All right. Well, I'll go ahead and share mine, but that's you would expect me to have gotten it. So let me see. Where the heck's my now that my Python tab, my notebook tab is active, I can say share. Is that my? Am I sharing the right tab? Y'all seeing my the exercise there?
I see it. Yeah.
Got it. Okay, cool. Okay, so the way I approached it was I used the numeral 2 in there, just like the all the boy bands. Celsius to Fahrenheit, because that's what we're doing. We're accepting degrees Celsius and returning the Fahrenheit value. So I named my function something I thought would be meaningful. and we're passing it in degrees Celsius. So again, this is the definition of a function. It's not doing anything until we use it later in that code cell. But I'm passing in C degrees, I called it for Celsius, and I'm calculating Fahrenheit degrees, and I cut and paste this formula right out of the markdown cell. But I made sure that I was using appropriate syntax. So for the degrees space C, and this degrees space F, which will barf, that's not proper Python syntax. You can't have a space in a variable name. So I renamed it F underscore degrees and C underscore degrees, but I used the exact same math syntax there. And then remember, we're passing in degrees Celsius and we're returning the Fahrenheit degrees that we calculated based on that formula. So return F degrees is the last line. So really the function's 3 lines. And then in order to use it, we got to call it somewhere. So I went ahead and did an input statement to get my degrees Celsius that I intend to pass to my Celsius to Fahrenheit thing. So I gathered that in integer or floating point format. Either one works, but I converted the input to float just in case, as is safe practice in Python. And then I printed what they typed in, and then the string degrees Celsius equals, and then I printed my function passing input temp as the parameter, the thing that I gathered in the previous input statement. And input temp goes into C degrees up here, and then you work on it as C degrees inside of the function, in degrees Fahrenheit. And then sure enough, you run it and enter a temperature in degrees format. So 45 is 113 in Fahrenheit. Whew. Pretty warm. Did anybody approach that significantly differently? Because I'm absolutely not saying that's the only way to do it.
I used my resources and went and copied it off of W3 Schools. However, it's about twice as long as what you just did.
Well, there you go. It might be more readable. You know what I mean? That print statement calling the function doesn't allow you to, you could format Celsius to Fahrenheit as a string using decimal points. And I mean, there's things you could do with it to clean it up. But I went for minimally effective Python and went with that. So, okay. Well, there you go. If I'll post that in the chat room in case y'all want to paste it in as an example of something that runs. And the chat window is chat. How do you chat in chat? There you go. I'm curious. Chat. It's not letting me chat. Because I'm screen sharing, maybe? Stop share. There's the chat window. Crazy. Well, that's not what I wanted it to be. Oh, yeah, it was. It's just really ugly in the chat window. I tell you what, if you want that code, snippet, because I had other examples. If you want that code snippet, shoot me an email and we can go over it. And if you ever want to get together one-on-one and kind of just go over some stuff, holler at me. I'd be happy to. I work from home, so I'd be happy to help go over any of this stuff that's kind of obscure. But I got one more notebook with 2 new data types that I want to talk about. Before I go on, anybody want to interrupt? Questions? Okay. So I'm gonna save my notebook number 6, and I'm gonna say File, Close and Halt. Away it goes. And I'm gonna go back and I'm gonna pull up number 10, Lists and Tuples. Okay. Share. Everybody got lists and tuples up there? My screen coming through okay?
Yes.
All right. Okay. I'm not looking at the camera, so if you're chatting or whatever, I may not see it. So unmute your mic and holler at me if you want me to slow down. I am recording. I am sharing. Okay. Lists and tuples. These are known generically in computer science as a sequence data structure. And they are just what they sound like, a list of things. And it's kind of like we've done before. Everything has it has an index. So when you're looking at a list of names, the first cell, the first item in the list is the 0th item, which, remember, Python is 0 based, which is frustrating, but we'll get through all of that. Now, the main difference between a list and a tuple, and full disclosure, I had never heard of a tuple before I started learning Python a couple of years ago. But that's what they call it. There was no such thing in my programming experience. Everything was called an array. But in Python, a list is mutable. You hear about these terms, mutable and immutable data types in Python. Mutable just means it can change. Immutable means it can't. So a list, you can change the values in the list. You can add, you can subtract, you can change the values at a given index in the list. But tuples are more like a lookup table or something where once you create it, it's set in stone. So so I'm trying to remember if the file that I uploaded, if I had copied and pasted the movies and employee list commands. Or did it just have student numbers equals? Anybody on the notebook you downloaded?
I'm looking at employees.
Thomas, can you see the code cell that I have highlighted?
Yes.
Does yours have all 3 commands that I have? Student numbers, yes, and movies and employee? It does. Okay.
Yes.
Yeah. The intention was for you guys to run it and then cut and paste these commands, but it was kind of pointless. So yeah. So when you run this is the command to create a a list. Notice they're in square brackets, and you separate elements in the list by commas. So that command will create them, and we run it. And then the next command, you don't have to print individual elements. You can print an entire list. And this is working with lists is one of the things that when we first started the course, and I was telling you, Python's amazing that you can do things with one line of code that you would have to write a bunch of code in a normal programming language, and we'll see a few examples of that here today. So if we run that, all we'll see is the stuff that we printed out, right? Or that we created. The next, something to notice here is that a list doesn't have to be the same data type. It's not like a column in SQL or a column in Excel. The items in a list can be different data types. Okay, and there's a built-in function that converts a range into an iteratable list where it automatically goes through it. So we're creating a list. This list function creates a list based on the range function that we covered in for loops. That's the same exact range function. All it does is create a range of numbers, starting with the first, ending with the second, and incrementing by the third number. So we see that this creates, 5, 10, 15, 20, all the way up to 100 in by groups of 5. And you can modify that if you want to prove to yourself that it does things differently. So we run that out and we see, up to but not including 100, because it's zero based and it's exclusive of the of the last number. That takes some getting used to. So so we did up to 5, or we started at 5, up to but not including the second number, incrementing by 5s. So we created a list called 5s in one easy line of code. I mean, just amazing. So you can also multiply lists, and Python knows, based on the data type, that what you're trying to do when you multiply a list is replicate it that number of times. So this next one is really just taking that 5s list that we made up there and tripling it. And when we run that and print it, we see it goes from 5 to 95 and then starts over again at 5 to 95 and then starts over again 5 to 95. And that may have some value to you, creating dummy data or something like that. So anyway, just showing you the syntax. You can access an individual element of a list, and remember we started to do this, and I was like, oh, I hate doing it, and I still do. When you do a for loop through a list, the loop variable, instead of being like I being controlled by the range variable where it's a number and it's going 1 2 3 4 5 6 7 8, when you use a list as what you're iterating through in a for loop, the loop variable is the values in the list, not the index number. So that won't, for I in student numbers, won't go 0, 1, 2, 3, 4, 5, 6, 7 for, you know, however many things there are in student numbers, it'll actually put the student number in num, which is just, for me, that's something to get used to. But so did we create student numbers up here? We did, didn't we? Yeah, we printed student numbers. So we are going to loop through student numbers, and you'll see what I'm talking about. And we'll loop through employee and print the loop variable in each one of these. Just to prove that the loop variable is the actual element value in the list. Okay. Next, we have some lesson. We use indexing to refer to the elements in a list. The index is the numeric value of the nth element in the list. Beginning with the first at position 0, remember it's 0 based. And it's a concept that beginning programmers and old programmers who learned in Pascal and C have a hard time with because it's different. So the index goes inside square brackets. So the movies index value 2 is actually the third movie, right? So index value, movie index value 2 should be Star Wars because it's the third element in our list. And this will prove that movies is Star Wars and employee is the first one. And if you use a negative number, it starts at the end and goes back that many. So movies -2, before I print it again, I'm thinking should be should be Star Wars again, but it might be the Blob. No, it should be Star Wars. Let's see what it, I mean, logically, we'll see what Python does. Yeah, Star Wars. It's the second from the end. Okay. Now, since lists are mutable, meaning changeable, we can overwrite the value of an element just like we would any other variable, using it on the left side of an assignment. So here we'll this next code block will print the employee list, and then we'll set the first to 999 and print it to prove it. And then all we're printing is the data type of these first 3 cells in employee. So I'll run that. Yeah, see, the employees have these different values, right? And they don't have to be the same value. Python will dynamically, automatically assign a value based on its rule set. So, that's why the 0th cell in employee is an integer. The second cell is a string, third cell is a float, and the data type of the entire thing is a list as returned by the type command. Okay. You would holler if you need me to slow down, right? I'm going to try and cover this all by 12:30. Okay, so these are lists. So here we can use the repetition operator, otherwise known as the multiplication sign, to create a list of 5 blank spaces. And then we can assign a value to whichever of those that we like. So when we run that one, it does exactly what you would think it would do. Sue blank Jimmy blank blank. Sue blank Jimmy blank blank. All right. And we can, if you use the plus sign, it doesn't it doesn't do math on the numbers inside of a list. It actually concatenates them. Just like the concatenate inside of a print statement. So that's familiar syntax. Okay. So we created a new list, faculty numbers, and we concatenated it with student numbers. And we notice it concatenates them to the end, kind of as you would think, probably. Okay. And then oh yeah, this is just using, remember, a combined operator. Instead of saying, something equals something plus something, you can do plus equals as a abbreviated format. So faculty numbers is this 3-element list up here. And now we're concatenating movies to faculty numbers. Okay, I wanted to make sure I'm reading before I run it. Poof, sure enough. So we can still use the same operators with a list that we can with other variables. Okay, and we can loop. We've already done it with a for loop, right? Didn't we use a for loop right up here? Yes, we looped through with a for loop, and it loops through the actual elements inside of the list, and then here's the syntax for if you wanted to use a while loop. But this is this works 6. But how did we know there were 6 numbers in there? What if I go 8 times? It does it 6 times, and then it goes, it falls off the edge of the earth. So hard coding a loop like that for a certain number of things on a list is unnecessarily it could have an error. So what we do is we use the length of a list. The len function is a built-in function that is expecting a parameter to be passed to it that is a type of data type list. So we use that function inside of our while loop. While it's less than the length of it, we print it. And we print it at the value of index, and then inside of our while loop, so that we don't get an endless loop. We always remember to increment our loop counter. Index plus equals 1. If you forget that step, bam, endless loop. Okay, and we can run that. So yeah, the 6 up here is the length, the return value of len. Pretty sure that's an integer value, and then it uses that to loop through 6 times. Because 0 through 5, 0, 1, 2, 3, 4, 5. So that's why it bumps out on the 6th one. Everybody doing okay? You would holler if you needed me, right? Okay. So these are, until you start using this stuff, it's okay that if it's glossing over it. That's what these notebooks are for, is to go back and look at the code that works and make your code look like that code. That's perfectly acceptable. I almost never do anything from memory. I couldn't believe I did that temperature conversion. with 5 lines of code. I was so proud of myself because I never code anything without looking at an example either from Google or W3 Schools or something. Anyway, so list slicing is kind of like substring. In fact, technically, I think a substring function that pulls out part of a string is technically slicing that string, and a string is technically a list of characters as far as the way they operate. So you'll see some similarities between working with lists and working with strings as far as that's concerned. So list slicing, we've got 2 required parameters and a optional. You don't have to include this step value. Start colon end will get you there. Starting value, ending value. It defaults to 1, so that doesn't have to be in there. Okay, and then we got some great examples down here. So we run this cell so we can make a new version of our movies list. Doesn't do anything or doesn't print anything, right? So all we did was an assignment statement in there. And then I commented these out so that we have to literally uncomment them and guess. So who's online with me? Andra, what are you thinking that first one, movies 2:4? You haven't uncommented it and ran it already, have you?
No.
What do you think? What do you think movies 2:4 will return?
No clue.
No clue.
Sorry to disappoint.
I'm sorry?
I said no clue. Sorry to disappoint.
Okay. Well, the first number is the index 2 of the list. So it would be not necessarily the second, because remember it's 0 based, right? So I'm expecting that first one to be the 3rd cell ending at the 5th cell. So I would expect it to return the values from Star Wars, Heidi, and It. That's what I'm expecting. Anybody else got a different bet? Okay, come on. Star Wars, Heidi, It. List slicing, start and end. Why? It's exclusive. That's right. I didn't read my up to but not including. There you go. I forgot. It's that last index value is up to but not including that one. Test start. That's funny. I missed that one. From the start position, up to but not including. So that second number, that explains that. And when we don't pass anything at the it defaults to the start position. So when we leave out this first parameter, it defaults to the start. So I'm expecting this one to be from the beginning, which is Scarface, up to but not including index 3, which is the 4th movie. 1, 2, 3, 4, up to but not including Heidi. So I'm expecting this to be Scarface, the Blob, and Star Wars. Scarface, Blob, Star Wars. Come on. Scarface, Blob, Star Wars. Scarface, Blob, Star Wars. Woohoo! All right. And then the next one, the first cell whoop, is actually the second one, right? And then if you don't pass any parameter in that second colon, it defaults to the end of the list. So this should be the blob through all the way through to the end. It is the blob through up. The next list slicer starts at 4th from the end and goes to the end. So it starts at the end, counts backwards 4 as your starting point, as your starting cell. And then it goes to the end of the list. So the 4th from the end is 1, 2, 3. So this should start at Heidi and go back through to up, I'm expecting. Yes, starts at Heidi and goes back through to up. And then if you send it nothing, well, I'm trying to remember what is that defaults to. I think that should be the whole list. I think that defaults at the start and it defaults to the end if you don't send the parameter in there. But you still have to slice it, or you are still slicing it. Let's see what that, if I'm right. Yeah, that because there's a use for that. It's different than just printing. Let's do another line here and say print just movies. Let's see what the difference is. It seems like it looks different. I'll start commenting some of these out that we don't need anymore. Oop. Oop. Oop, oop, oop. Okay, so now we're printing movies using this slicing thing that we tried before, and then we're just printing movies. But it seems like there's a difference. Yeah, not in display. Anyway, we'll get there. Okay, so this last one, we're printing starting from the 1, which is actually the second in the list, going up to index 4, but not including index 4, and we're going every other movie because we've added that third parameter, which is the incrementer as we go through that. So I'm expecting the blob and Heidi. But Heidi's, yeah, and 4th is actually it because it's 0 based. So I'm expecting the blob and Heidi. We'll see here. Woo, the blob and Heidi. Match made in heaven. Okay. So yeah, that's how you subscript or slice, depending on how you look at it, a list with a lot of different examples. If you ever are doing a coding challenge and you need an example, this is a good notebook to fall back on. The in operator is just like we used in SQL. SQL had an in operator to check if something existed within a list, and that's exactly what it's used for here. So when we run this, we're gonna enter a movie name, and we're gonna look in using the variable, the input variable search, and the in operator. That's not a function, not an object. It's an actual operator. So I'm gonna run that, and I'm gonna put Silence of the Lambs. Not found. Run it again. It found it. So it automatically searches. I'm sure it's a sequential search. There are smarter ways. If you've got a list of 2 million things, there's better ways to go at it. But that's a basic search function. Okay. Okay, now what do I got? 15 minutes left. If I don't get any further, I need to make sure that I thoroughly confused you when it comes to what a method is and what an object is. Without going deeply enough, but not too deep. In programming, in general, you can create you can write the code almost kind of like we were creating a separate function that we can then call, that we can then reuse, and it's modular and it's out there. And you only, if you're going to modify it, you only have to modify it in that one place. You can create what are called objects in your code, which are templates for a thing. It could be like, if you're playing video games, it could be a car or a non-player character that's running around, and that non-player character can do things. So it will have functions associated with it, and it'll have attributes. So it'll have, things about it, like the type of character it is, how much ammunition it's carrying, what uniform it's wearing, what its health points are. And then when you're writing a large program, if in that program you need a new player character, you just, inside the code, you just say new player character and pass it the attributes that make it look different than another player character. And it may be the same uniform, the same health points. It doesn't have to be different. But then each one of those player character objects running around in your game that you're writing are independent of each other. And you can, you refer to them with a name, but in the code, it's a lot more elegant. So objects and object-oriented programming are kind of a way to modularize your code so that it's cleaner and more elegant. So back down here on Earth, where it's nice and simple and easy to understand, a list is an object. And each list you create with a name, like we've got list movies, and we've got, student numbers. We've got a few lists we got going here. Movies, what have we created? Movies, students, and is it employees? Employee. Student numbers, movies, and employee are all objects. Each one of them is a list object that you can refer to by its name, student numbers and movies. And even though they're all of the same type of object, they're individually, they have an individual life inside the program. However, objects of the same type of object all have what are called methods, which are really just functions that apply only to that type of object. And they are created in the library, in the code, in the language. Sometimes what you want to do will be a built-in function, but sometimes what you want to do will be a method that is kind of unique to that object type, like we're about to go into here. I hope I haven't thoroughly confused you. Oh yeah, I wanted to, yeah. And I think enough of you are new enough to coding that object-oriented is going to be like, what? Because it's still a little confusing to me, and I've been working with it in different at different levels for a lot of years, and it's still pretty complex to really wrap your head around. But that's what's going on. So movies, student underscore numbers, and employee are lists, and lists are a type of object, and list objects have cool methods, things you can do, functions that you can do to them by using this dot notation. So like there's a method inside of the list data type called append. So I don't have to say, movies equals movies plus Spartacus, or that just like you might think. I can use this append method that will append Spartacus, the movie Spartacus, to the end of my list. And append is a method. And in a minute here, we're going to see how it's really easy to bring up all the methods that are associated with the list object type. But strings are also an object type. Pretty much everything in Python is an object that has methods, but then there's functions that are expecting that type of thing to be passed to it. So it can be a little confusing, and that's why we do hands-on practice and coding challenges. So all this does is prints out the movies list and appends Spartacus to the end. There you go, Spartacus. Here we go. In this next cell, type in movies dot and hit tab, and you'll see the little pick list. Like whenever you hit tab in Python, it gives you things to choose from. It guesses what you wanted. So when you type in tab here, you get all of the methods that operate on a list type. So clear will clear out a cell, and these are all in the documentation. Depending on the way you like to consume documentation, it's either up in the help screen or out on the internet somewhere. So yeah, count is the number of things. You can. I could have swore you could like sum, but maybe I'm thinking of something else. I don't want to get ahead of myself here. You can sort the list by just using the sort method. You can sort it in reverse order by using the reverse method. I don't know what all of these do. I would have to play with them all or look at the documentation. But those are methods associated with the list object type. And you'll run into that with other data types are actually object types. Like a string is a string object that has methods associated with it. All right. So here we are printing movies. We're inserting these 5 insert statements. I'll let you read the rules. The normal ones do what you'd think. In the 4th movie will now be the movie Ben. A value outside of the bounds of a list in the positive direction will go to the end of the list. It'll tack it on at the end automatically. It won't error and fall off the end of the earth like it did in the while loop. Because the insert method does some error checking. That insert method is code that somebody wrote that looks a lot like a function. In fact, it probably is a function within the declaration of the list object. Actually, the list class. I don't want to get too far into that. Okay. So anything negative that starts at the end and then goes back before the beginning of the list puts it at the beginning. And yeah, -0 is an invalid negative, so it just puts it at the beginning. So if we run that cell, we'll see the result of all of those insert statements. So we've got it in there a couple of times now. So here's another method. I'm going to run out of time. I don't know if I can get to all this in 7 minutes as slowly as I talk, but some of this is working with files, which I wanted to do separately. So I think I'll get as far as I need to get here pretty quick. Yeah, that's what it was. When you're copying a list, Python will barf if you just say the data type, like you could with A equals B. You have to use the substring notation, or the slicing notation. So print will now, or cinema will now equal the movies. The movies list, the movies object. Okay. So an empty bracket is an empty list. But we can create this list shows by using the append. And remember, if you use this item as your loop variable in a for loop, it will return the items in the list, the elements in the list, not the index. So all this does is for each item in movies, it's appending that item to shows, and then shows looks a lot like exactly like movies, but you did it in a for loop. I mean, this is so much easier. Anyway, but there's more than one way to skin a cat, and that's why we show it. There you go. And what happens if you do like that? Is it doesn't copy, it doesn't make a fresh copy and put it in films. It only makes something that points at the same area of memory that movies is stored in. I apologize. This is getting complex. I would normally take a lot longer to cover this. So we may come back right around here on Thursday. So films equals movies works. It doesn't error. It creates films as a pointer to the same area of memory as movies. So that if you modify movies, you are also modifying films. And that's it's called passing by reference, not by value. That's why when you're making a no kidding fresh copy and you want to change films, you need to do it with one of these other two methods, so that you're actually getting your own duplicate copy of all the values in memory. See, when we appended Get Out, we appended it to movies. But when we printed films at the end here, it's in films, which is counterintuitive, but that's the whole pass by reference, pass by value. It doesn't come up all that often, as long as you kind of recognize what you're doing in Python. You shouldn't get tripped up too much. So I'm going to pause here. There's more to this notebook if you want to work ahead, if you're just thrilled to death with what you've learned so far and want to keep going. But I'll pick up here next time we talk about Python, which Yeah, I should be able to finish this up on Thursday. I need to finish it up on Thursday so that we're ready for pandas on the following week on June 8th. Okay. Any burning questions? Anybody? Let me stop share. If I were you, I would want to do some hands-on with that stuff, working with lists. Using those examples, playing, going, oh, no, I screwed that up just like I did with the fourth. It's up to, but not including. And you learn that way. You learn by breaking things. That's what I do anyway. So we'll finish this out, but then I'll have some exercises. So Thursday, this coming Thursday, the 27th, we have a guest speaker who I'm actually going to be on the horn with here in 30 minutes. Jeremy, who is Chaz and Andra's mentor at CAE, is going to show us this tool that they use called Domo. I'm going to give you a little walkthrough of Power BI in the vein of that, even though none of you are using Domo except those two, and they've got expertise there. None of you are using Power BI, but I'm gonna show you how it works and what a basic workflow looks like in Power BI. It looks a whole lot like Excel. That's right. If you know Excel and you're comfortable with it, Power BI is not much of a stretch at all. But Power BI sucks for Apple users. So you guys are using Google Data Studio. Are Aaron or any of you, Laura, are you proficient enough in Google Data Studio to do a real simple walkthrough of acquiring a simple data set, even an Excel spreadsheet, and maybe like just drawing a scatter plot or that sort of stuff?
Yeah, I can do that.
Cool, Aaron. I'm gonna pick on you or lean on you Thursday morning. Will you be here Thursday?
Yes.
Okay. So it'll be half hour, an hour, 10-ish. If you have a meeting or something that creeps up, if you could be done by 10 or so. Otherwise, I know life happens. So yeah, I'd love to see it. I subscribed to it, started dorking with it. It's like there's so many of these tools. I know a little bit about Tableau, a little bit about Excel, Power BI, Google Data Studio, some of these other things, and it just winds up being this giant dirt clod in my head of where buttons are and how functionality works and what the terminology is between all these different tools. So that's what we'll do on Thursday, is look at some different visualization tools that do what we've kind of been messing with in these different sessions. And then next week we're off. June 8th is really important to be here. The following week, Mike Ellis will be doing pandas, which again is when you're in Excel and you're looking at columns and rows and you're changing a column name and you're maybe doing some calculations on a column and plotting and whatnot. I want to plot these two columns in a scatter or in a bar chart or whatever. Pandas is at the heart of all of that. And pandas is from what I hear, is what has allowed Python to kind of catch R. And in some circles, as far as the number of raw users, it's kind of passed ahead as far as its appeal, and it's now being used. I know Field Agent uses Python as the back end of their web application. So instead of Java or C#, or Ruby on Rails, it's getting to be really popular. But anyway, that's what we're doing on June 8th. And then one more thing on your calendar I wanted to chart out, and that is also Jeremy, who I'm going to be talking to in 27 minutes. Jeremy is doing a day in the life of. Chaz, Andre, do you know what day he's doing that? He's doing our little demo on the
That's actually the
27th.
first I'm hearing of that one.
Really? Yeah, he's the week of the day
I'm
in the
checking
life.
my email here.
Ha! I got it. It's on June 17th during our class, but it's so applicable. I'm going to go ahead and let that be the last bit of the day on June 17th. Jeremy, when he was going through this course, I mean, he's, rock star, like, some of y'all. He told me, he says, I'm really a data engineer more than a data analyst. But he's pretty smart all the way around. So he is doing a session at 11. I'll get you guys the login for it, but if you'd mark your calendars, it's during our class, so your calendar should already be marked. But he's doing a day in the life of a data engineer, and this is something that ACDS sponsors, and he'll have people from around the state. Last time we had, I don't know, maybe 30 or 40 people, and it was a day in the life of a senior software engineer. I think it was like Accenture. Anyway, it was a company that I'd heard of, and it was interesting listening to that perspective. Well, data engineer is actually much closer to what you guys. You'll either work with a data engineer or you'll be doing your own data engineering to prep your data for your projects. So the more you know about that world, the more you know how to communicate with them, or where the line might be drawn between a data engineer and an analyst. We'll get Jeremy's perspective, and this is Jeremy's perspective at CAE. It's and I'm sure he would share with you. It's what it's like for him as a data engineer. So yeah, during class on the 17th, if you're able to make it. Any questions before we reconvene Thursday morning at 8:30? Everybody good? Going once, twice. Okay. See you Thursday, guys.
Thank you, Don.